Hello and welcome. I'm Greg Johnston. I'm a senior application specialist with sensors and software, and I've been with the company for 27 years. The topic today is using the LineView module, which is part of the EKKO Project GPR analysis software. LineView is the software we use for plotting GPR lines, also known as GPR cross-sections. When you are collecting GPR data, a cross-section is what you see on the screen of the data logger. Whether you have a single GPR unit or some fancy multi-channel GPR system, a cross-section or multiple cross-sections is what you see. They are the building blocks of GPR data. Cross-sections are also what most people use to interpret GPR data. So it's very important to know how to plot GPR cross-sections the best way so that you can do the best job interpreting them. This is something near and dear to my heart. I have trained people on GPR for more than 20 years. And as a GPR practitioner, you must be able to plot GPR lines effectively. This is the only way to understand the data you're seeing and extract the most information you can out of it. If you leave this webinar or a Sensors and Software GPR training course with that knowledge, I'm a happy trainer because I feel I've done the most important job in your GPR education. Okay, let's dive in. One of the big advantages of using GPR is that you get a real-time image of the cross-section data. However, the data are also being saved for later review and plotting on a PC, and that is what the EKKO Project software is for. EKKO Project is the software that I'll be using today. Here's the main screen of EKKO Project. Hopefully you've seen some of my other webinars explaining what the main windows of the EKKO Project software are and how to open GPR data in EKKO Project. My data that I'm interested in looking at today was saved as a project file with a .gpz or gpz extension. So I'm going to browse and open it. So I'm going to browse for my file, and this is the one I want to open up called GPR data, which you'll notice is a GPZ file. When the GPZ file opens, you can see the various windows populate with images and information. Project Explorer, on the window on the left, displays the folders and names of all the GPR lines in the project. The Line Preview window displays the first line in the GPR project. The Acquisition tab gives us all the information about the details of how that GPR line was collected. The date, antenna frequency, length of the line, step size, etc. Scroll down through this list to see all the details. For example, in this particular data set, line 1 was collected with a 250 megahertz system. It is 34.5 meters long, and the step size was 5 centimeters. And if you dig down in here under the advanced, you see the total number of traces that were collected was 691. Because this GPR project was collected with GPS, we can see the data collection paths of the lines displayed in the map view window here. Okay, back to Project Explorer. This window displays the names of all the GPR line sets and grid folders. In this case, we only have one line set, and we have no grid folders. It also displays the names of all the GPR lines in the folder. If you press the minus sign here, you can collapse the names back into the folder name, just like Windows Explorer or other software you've used in your life. Okay, now this is a webinar about LineView, looking at GPR lines. If I want to plot a GPR line in the LineView module from EKKO Project, there's 4 ways to do that. I can select the name of the file, and then I can go up to the Tools menu and select LineView. That's number 1. I could also select the name of the file, and I could click on the LineView button from the toolbar. It's number 2. Number 3, I could right-click on the file name and I can select LineView from the submenu that appears. The last way is the one that I think is most intuitive. If you want to see the GPR line in LineView, just double-click on it. So I double-click on it, and it opens up. When a GPR line is opened, it's plotted in a window within LineView. So right now, if I do this, it's plotted as in full window mode. If you want to see the line in a smaller window, press the middle button up here. It's technically called the Restore button, but it is the one that shows 2 small windows. Now you can click and drag the window anywhere within LineView. You could grab the edge of the frame and you can expand it or contract it. You can grab a corner, you can change the aspect ratio, all standard Windows stuff. Now, I'm going to change the display to a full screen mode for now. Now let's discuss the different parts of the GPR line. The GPR data typically consists of dozens, hundreds, or even thousands of vertical strips of data called traces. Each trace is collected at a specific position on the surface. Traces are typically collected and plotted at equal intervals. The distance between traces is called the step size. In this case, you'll remember that this line has 691 traces, each one 5 centimeters apart. If you do the math on that, you end up at 34.5 meters of data. Trace collection is typically triggered by an odometer on the GPR system, but data can also be collected in free run mode or by simply pressing a button to collect each trace. The position axis for the GPR line is plotted along the top of the window. In this case, the position scale shows us that this line is 34.5 meters long. This data was collected in metric, so the position axis is plotted in meters. However, in LineView, all distance units can be quickly changed from meters to feet or feet to meters by clicking on the units buttons on the toolbar, these ones here. So if I click on feet, now you'll notice that the position axis and the depth axis now display feet. Now the line is about 113 feet long and the depth scale is about 11 feet. The time axis is on the right side of the plot. Remember that GPR data is collected in time, usually nanoseconds, which are billionths of a second. 20 nanoseconds is approximately 1 meter of data. GPR data are collected in time, but no one looks at this response here and says, oh, hey, this target's 20 nanoseconds in the ground. We want to know how deep it is in distance units, like meters or feet, so we understand it better. So we need to plot a depth axis, and the depth axis appears on the left here. And it's obviously way more understandable than the time axis. Many of you will know that to get the depth axis, we need to convert our time measurements to depths. So how do we do that? Remember the velocity calibration you do out in the field? Remember fitting hyperbolas so they match the shape? When you do this, you are measuring the velocity of the GPR signal in the soil. And it is that velocity value that is used to convert the time scale to a depth scale. This is the reason why the depth axis has a velocity written on it. In this case, the velocity is set to 0.328 feet per nanosecond. And if I switch the units, 0.1 meters per nanosecond. Because if the velocity changes, the depth scale changes. Let me show this. Recall that for velocity calibration to work best, it's important that the target is crossed perpendicularly. If it's a utility, make sure that you've crossed the utility at 90 degrees before doing a velocity calibration. In this case, you'll need to trust me that this line crosses the targets at right angles. If I put my mouse cursor at the top of the highest band, which I'm going to call the white band, on this object at position 14 meters or so, The depth is written on the status bar on the bottom edge of the screen, down here. Okay, so if I put my mouse back at this position, this suggests that the depth of this object is about 1.05 meters. So that is the depth based on the current velocity of 0.1 meters per nanosecond or 0.328 feet per nanosecond, which is actually the default velocity. That's the velocity we use when we don't know what the real velocity is. But in this case, we have beautiful hyperbolas that we can do a velocity calibration on. LineView has the same hyperbola fitting tool that you've seen on the GPR system out in the field. To open this up, it's the toolbar with the red and blue hyperbola on it. I can click on top of it and move the hyperbola over onto the target hyperbola and place it on top. Then I can grab the tails and I can drag them so it fits the shape, somewhere around there. So that seems to be a pretty good fitting. Again, if I look down on the status bar on the bottom edge, this says the velocity I've just calibrated is 0.123 feet per nanosecond. Now, I can apply that measured velocity value to the depth scale by clicking on the hyperbola button on the toolbar a second time, and it's going to ask me a question: do you wish to change the velocity? I'm going to say yes, but I want you to watch what happens. The GPR image does not change at all, but the depth scale does. Now, if we check the depth of the same object as before, we see that the depth is now 1.31 meters. Remember that it was 1.05 before. So the velocity calibration has improved our estimate of the depth of this object by 26 centimeters, which is about 10 inches. So this is way more accurate than it was before. So you'll know the more accurate the velocity value, the more accurate the depth estimate of the target. Now that we have made the depth axis the best it can be, let's look at the GPR data image itself. LineView always plots the whole GPR line on one screen, no matter how long or how short it is. In this case, the 34-meter long line looks pretty good on one screen. So before I show you the zoom buttons, let's open a GPR line where the zoom buttons are going to be very important to understand the data. Here you see a GPR line that, according to the position axis, is 1,000 meters long. It has 20,000 GPR traces, and the whole line is plotted in one window. So it's very compressed horizontally. So let's look at the 4 zoom buttons. These are the zoom buttons on the toolbar here that control our ability to zoom into the data. The Zoom Plus button expands the horizontal position axis, plotting less data in the window. It's typically used for zooming in on targets of interest. So every time I click it, the length of the plot doubles. And now I have a slider bar on the bottom edge of the screen if I want to move through the data. So I want to look at something at around 750 meters or so. So I'm trying to scroll over into this area. Now, if we want to see individual targets on this GPR line, we definitely have to zoom in. Each time I click the Zoom Plus button, the length of the GPR line doubles in length. So watch what happens here. Watch how these targets widen from vertical strips into hyperbolas as I double the length each time. Now, you can also use the left and right arrow keys to move through the data, and you can also use the page up and page down keys on the keyboard to quickly scroll through the data. Or you can use the slider bar along the edge, on the bottom edge of the screen. Now, there's the Zoom minus button. It does the opposite. So if I start clicking on it, it's going to put less data on the screen. It compresses the horizontal position axis and gets shorter and shorter. And if I go right down to, here's Now I'm looking at all the way down to, now I'm less than one screen. So the full 1,000 meters of data, in this case, if I click it one more time, is now displayed on the quarter of the screen. So the data is really, really compressed. So let me expand it out. And I want to look at something in particular at around 850 meters. So I'm going to expand out here, and then I'm going to scroll over to the 850 meter mark. If you want to look at data in a particular area, you can click on this zoom button, which allows you to drag a box around the data. So I'm going to click on that. I'm going to click in the top corner. I'm going to drag to the bottom corner diagonally, and I'm going to let go of the mouse. And at that point, it zooms into that box that I just drew. So you can see here, we got a real zoom in on this particular feature that runs from 834 to 850 meters. And we're going to be looking at the nature of that a little bit later. Okay, to unzoom from the box and return to the full data image in the window, the last zoom button is the one that has a picture of the globe on it, which means fit to window. So when I click on that one, no matter how zoomed in I am, it puts all my data onto one screen. All right, so that's how to zoom in and move around along GPR line. The next thing we need to do to optimize the GPR line image is to work on the gain applied to the GPR line. Let's review the concept of gaining data. As GPR signals travel into the subsurface, they get absorbed and weaken. How quickly the GPR signal gets absorbed depends on the electrical conductivity of the soil or the material that's being scanned. Soils with high electrical conductivity absorb GPR signals faster. For example, many people know that clay soils are not good for deep penetration with GPR. Clay is like the animation on the right side of this image. In a clay soil, the GPR signals get absorbed very rapidly because clay tends to have a high electrical conductivity. The GPR signals drop below the level of GPR sensitivity, also called the noise level. They drop behind that quite quickly, so the penetration depth may only be a few feet. A coarser grained soil like silt, depicted in the middle of this animation, has lower electrical conductivity. The signal absorption is not as rapid, so the GPR signal travels deeper before it drops into the noise. One of the best materials for GPR that a lot of you will know is sand. And this is kind of shown on the left side of this image. Because sand generally has low electrical conductivity. Signals travel deeper before getting absorbed. Okay, the concept behind gaining data is to amplify the weaker signals from deeper in the cross-section so that they're visible in the plot. Since GPR signals are strong at the top of the GPR line, little or no gain needs to be applied. But deeper, where signals are weaker, more gain is applied. So a typical gain function is a ramp, and it's applied to each GPR trace. So you can see in this depiction here, we start off with very little gain, and as we go deeper, where the signals are weaker, we're applying more and more amplification to the signal in order to see the signals. Back at LineView. Now here are the toolbar buttons that affect the gain. This one, there's a little drop down that says auto, and then I've got this plus and minus that are grayed out right now. So LineView will gain the GPR line with either the gain that was used on the DVL or on the data logger when the data was collected, or it will use an auto gain. If you look at this little window here, it will usually say auto or user. The auto gain attempts to automatically gain the data based on the attenuation of the GPR signals with increasing depth. The auto gain usually does a pretty good job, but it might not do the best job. And now is the time to do the best job gaining the data so we can make a great image for our presentation or our report. So even if you think the user or the auto gain looks good, what I tend to do is I'll run through the 12 different numbered gains to see if there's one that makes the data look better. To do this, click on the drop-down list and where it says auto and change it from the word auto to number 1. Now we can see that a gain of 1 is not enough gain. So we want to increase the gain to number 2. Now rather than using the drop box again, the faster way is to click the gain plus button, which is now enabled. And this is just to the left of the gain drop down. So if I click on the number plus, now I'm at gain of 2, gain of 3, gain of 4, 5, 6. So I'm increasing the gain each time I click on this. You can see the gain looks pretty good. Now I might say we're getting a bit overgained, and now I've hit the maximum of 12. And at this point, I would say the data is way overgained. All the signals are black or white with very little gray visible in the image. So a gain of 12 does show all the signal, but it might be difficult to interpret. And we cannot say which reflections represent a large change in materials and which ones represent a more subtle change because all the signals have been greatly amplified. So now I'm going to use the gain minus button to reduce the gain, down from 12 to 11 to 10 to 9. In this case, a gain of 9 seems to make the data look the best. Now 9 is pretty high, and that high value suggests that the soil at this site has high attenuation. So the gain that we're using on this data is higher than average. But what we see is a gain of 9 is enough to see the signal all the way to the bottom edge of the screen. We see this fuzz or the snowiness from the background radio noise. That is the best way to determine if you've applied enough gain. The bottom of the record should never be blank. For example, if I take this down to a gain of 4, look how the bottom of the section is actually blank. A GPR image is never blank or constant. There's always signal there, even if it's just the background radio noise. So let me take that back up to 9 quickly. All right. We can also tell in this type of plot which reflections represent strong changes in the subsurface. For example, all these hyperbolic responses that we're seeing in here that are probably utilities or other objects obviously are contrasting with the soil a lot more than some of the other reflectors. And this is very useful information. Now remember, there's no perfect gain. It is something that you may have to play around with to make your GPR line look the way you want. And everyone will have slightly different preferences, and at times you might apply a higher gain or a lower gain in order to emphasize the thing that you want to emphasize in your data. The next feature that I would like to talk about is the background subtraction filter. When you are collecting data in the field, this is usually just called filter on the data logger. What it does is remove flat-lying banding in the data. You apply this filter by clicking on the BKG sub button, which is right beside the gain buttons on the toolbar. Now look at this line I just brought up. It's 129 meters long. And watch what happens as I turn the filter on and off. Do that a few times to show you the effect. Notice how these flat-lying bands down here are largely removed by applying this filter. Now, these flat-lying bands are often interpreted as being real. If you watch some of my other webinars, you'll understand that these are not real subsurface reflections. These are banding in the data. It's called system noise. And so that people don't misinterpret it, you often want to remove that. And the background subtraction filter is a very effective way of doing that. So the filter is very handy for these banding type artifacts. Now let me switch to another line here to make another point. The most common flat-lying band in the GPR cross-section is the transmit pulse. the first energy that arrives at the GPR receiver right at the top of the GPR line, up here. The nature of this energy is explained in the webinar called Data Interpretation Part 1. So I'm not going to spend time now explaining why it's there. But if we are looking for a very shallow object, the background subtraction filter can be beneficial to remove this band of energy from the data. Watch what happens around this 55-meter mark. Let me zoom in a little bit. And let me apply this filter. Now look in this area in here. Boom. Let me filter this out a little more, move over a little bit. What I'm looking at is this hyperbola right here. Look at how that hyperbola appears. It is very masked by the transmit pulse, by this pulse at the very top. When I apply the background subtraction filter, there it appears. So it helps us to find very shallow objects, or in general, objects that are obscured by banding in the data. Okay, now I'm going to switch to another line here. Now I want to apply the background subtraction filter to the other line that we were looking at earlier. You'll notice if I zoom in around the 500-meter mark, there's a whole series of, look at these flat-lying features in here, these flat-lying reflectors. And if I turn on the background subtraction filter, you might think that those are going to disappear. And they didn't. So why didn't that get filtered out? Well, the reason is that they're not flat enough for long enough. So the background subtraction filter actually has a width to it. The default width is the full length of the GPR line. So this means that only flat-lying reflectors that are present on every GPR trace for the entire length of the GPR line are filtered out, like the transmit pulse we talked about, and like the system bands, system artifact bands we just looked at. Those are the things that typically get filtered out by using a background subtraction filter with the full width of the section. But what if like this GPR line, I have some localized flat-lying reflectors I want to filter out? To do that, shorten the width of the filter. Now, changing the length of the filter is not in the toolbar. We must dig into the menus a bit to find it. And this menu is actually found in the View Settings menu. So View Settings you can either get at by going to View and clicking on Settings, or you click on this button here, which shows a slider bar with yellow, green, and blue slider bars on it. Now, a dialog box opens that has multiple tabs on it. We're going to look at all these tabs later, but right now I just want to select the one that says Gain and Filter. Now, this admittedly is a very intimidating dialog box, but for now I just want to look at the filter width parameter, this value right here. You see the filter width is set to full length. So I'm going to change that value, use the drop down, and I'm going to change it to 10 meters. And then I'm going to click on Preview to watch what happens when I reduce the length of the filter from the full length of the line to 10 meters. And you can see that more flat-lying features have been removed. Let me now change it from 10 meters to 5 meters. Press Preview. More flat-lying features are removed. Let me go from 5 meters to 1 meter. More flat-lying features have been removed. If I set it to 1 meter, it has removed any flat reflector that is 1 meter or longer. So you compare. So let's compare the system with no background subtraction here and with a very severe background subtraction applied with a length of 1 meter. Look at how it removes all those flat line boundaries. The background subtraction filter is a very powerful processing tool. It is great for emphasizing hyperbolas in the data, but obviously be careful using it if you're interested in seeing flat line boundaries. Now at this point, I've done most of the technical things to optimize the image of the GPR line. We've applied a gain, we've done a velocity calibration so the depth axis is accurate, and we've experimented with the background subtraction filter. Now I want to talk about some of the other buttons here. So I'm going to switch back to another data set, this one we were looking at earlier. Now, some people like to plot their GPR data with grid lines superimposed. And there's a button up in here which shows a picture of grid lines, and it turns grid lines on and off. Let me turn that on. It just toggles them on and off. Now, grid lines are vertical and horizontal lines plotted at the axis label intervals. The grid lines are turned on and off by this button I've just pointed out here. So that's sometimes a useful tool that if you want to have the grid lines on your data. Another button is the measure tool. The measure tool is the picture of a ruler here. When I click on that button, I go into measure mode. And now I can measure the distance between any 2 points in my data by clicking and dragging and dropping. Now, the distance that it just measured here actually appears on the status bar in the bottom left corner. So these two objects are approximately 5 meters apart, according to the measure tool. Measure tool is a mode so that when I want to get out of measuring, I click on the button again to turn it off. There's another button here with a green L on it, and L stands for legend. The legend is the text that appears under the GPR line image. It lists information about the GPR data file, including the name, the date, the antenna frequency. The legend also lists details of how the cross-section was processed. For many people, this is critical information to show with the data plot. But if you don't want to have it, you can remove that by clicking on the legend button. The legend button will turn it off, turn it on and off. So if I turn it off, I got a little bit more real estate and I can make the cross-section a little bit bigger. Now in a few minutes, I'm going to show you how to modify the items and the order of the items that appear in the legend. Now the status bar on the very bottom edge of the screen. I've already talked about the status bar a few times during this talk, but I want to talk about it in a little bit more detail. Notice that as I move the mouse cursor around the GPR image, the numbers are changing everywhere on the status bar. And that's because it's giving me all kinds of information about the position of my mouse cursor. For example, if I stop the mouse cursor here, I get the information about the current depth that it's at, the time it's at, the signal amplitude at that point, the trace number in the data file, the sample point of the trace. There's also displays GPS information, if available. So you'll see the GPS values changing on the bottom edge of the screen. Now, speaking of GPS, if your GPR line was collected with GPS, we want to come back to this line we were looking at earlier. And if I plot the whole thing, you'll recall this very interesting area over here at about 850 meters. So I'm going to zoom in, and then I'm going to scroll over to the 850 meter mark. And we're going to have a closer look at this. Let me just zoom a little bit more in. And so, for example, this might be something that we're particularly interested in. Like, what is going on here? This area is different than anywhere else in the GPR cross-section. Well, this data was collected with GPS. And so there's a connection between this line and Google Earth. So if I move my mouse cursor into this area where this strange response is, and I right-click, there's a little menu that opens up and it says, show me this spot on Google Earth. So I click on that, And if you have Google Earth on your computer, it automatically launches Google Earth and it will fly into that point and it will place a flag where your mouse cursor was. So let me zoom in. Let me have a look at this area. And now I'm starting to understand my data a bit better. When we look on Google Earth, we quickly see that that part of the GPR line was collected across a footbridge that's going across this creek. So this is a very easy and powerful way to connect your GPR line to the context in which it was collected. It's a great tool for assisting with interpreting GPR data. Sometimes you'll see responses in the GPR data that are baffling, but once you see where the data was collected, the response will be explained. Okay, modifying the background subtraction filter length introduced us to the View Settings button. Let's start using the View Settings to modify the cosmetic display of the GPR data. So I'm going to click on the View Settings button here and open this dialog again that has the 6 tabs in it. And the tabs are called General, Color Palette, Gain/Filter, Axes, Limits, and Legend. So the General tab is where we go to change the font used on the axes and the legend. If you click on the font button, it opens up the standard Windows dialog for changing the font style, the size, the color, all those things. So if you want to use a certain font with your GPR data, you can do that here. The next tab is called Color Palette, and it's used to change the colors of the GPR data. Remember that GPR signals travel as a wave into the subsurface, just like throwing a rock into a pond and watching the ripples travel across the pond. Waves have troughs and peaks. The troughs are negative signals and the peaks are positive signals. In this example, the strong positive signals are plotted in red, and the strong negative signals are plotted in blue, and the weak signals around 0 are plotted in white. So remember that the GPR reflection strength depends on the contrast in the materials. The larger the contrast, the stronger the reflection, and the attenuation of the signal. The more attenuation, the weaker the GPR signal gets. This means that the strength of the GPR signal is depicted using the colors in the color palette. Okay. So let's look at 5 different color palettes. Now first I'm going to check this little box here called Auto Preview. So that means, when I do that, the colors will instantly update. Now the default color palette plots the extreme negative values of the signals in black and the extreme positive values in white. And all the other values, the values around 0, are going to be in gray. So that's this type of plot that we're looking at right now. Now there's a list of different color palettes here. So if I switch from the default one, let's look at the one called Copper. So Copper plots the extreme negative values as black and the positive values as sort of this copper color. And you can see the way it makes the data look. Let's go from Copper to one called Hot. So this plots it with black with the extreme negative, white with the extreme positive, but kind of fiery colors in between. There's also a color palette called Jet, which is a popular one. So that's red and blue with greens in between. And the 5th one we're going to look at is the one called Seismic, which is red-blue on the extreme positive and negative, and white in the middle. So these are all the different types of colors that you can have, and there's more in that drop-down list. So my advice is to choose the color palette that best tells the story you're trying to tell with your GPR line. But me, for after 20 plus years of looking at GPR data, I still prefer a grayscale color palette. Maybe that says something about my personality. All right, you'll notice on this tab, there's also these slider bars called sensitivity and contrast. So after selecting the color palette, you may want to adjust the image using the contrast and sensitivity slider bars. Sensitivity defaults to 100% and contrast defaults to 0% or no contrast. So the best way to see the effects of changing the contrast and sensitivity is to select the auto preview checkbox, which I did before, and then start moving the slider bars and see what they do. Notice as the sensitivity is reduced from 100%, the color used for zero signals and weak signals around zero expands and gets wider. This removes the weaker signals in the cross section and only plots the strongest ones, as you can see here. Now, as I change contrast from 0% up to some other value, it makes the strong positive and negative signals get wider. So this makes the weaker signals in the cross section appear stronger. So as I increase the contrast, the weaker signals get stronger and stronger. So you modify these values using the slider bar. And you modify them to try to emphasize the part of the GPR signal that you want to show in your plot. I'll also point out that if I go back to in LineView, I can change the sensitivity and contrast values using these 4 buttons in the toolbar. They increase the values by 5% each time you hit the plus and minus 5% each time you hit the minus. Personally, I never use the contrast and sensitivity. I really prefer to modify the image and the strength of the signals using the gain. Okay, now that I have talked about color palettes, I want to jump back to the general tab for a second. And on here, this is where we can change the display of the GPR traces. Traces default to being plotted in color scale, which uses the current color palette. Now, I wanted to point out this box called Interpolation. Interpolating your GPR data removes the blockiness or pixelation when you really zoom in on the data. So for example, let me zoom in, make this hyperbola quite a bit broader, and then I'm going to turn the interpolation off. Hit preview. Notice the blockiness. Well, the blockiness is the reality of the data. Each block is 1 step size in width. So in this particular case, data was collected every 5 centimeters. So these little blocks here are each 5 centimeters wide. We make them look smoother by clicking the interpolation button on, and it smooths the image and makes it more pleasant to look at. In general, you should leave the interpolation enabled for all your plots. Now, you can also see the option for wiggle trace. I am going to discuss wiggle trace plots and combining wiggle and color scale plots in the next webinar, which I'm going to call Advanced Features of LineView. The next tab is the Axis tab. A GPR line can have up to 3 axes: the position along the top, the time on the right side, and the depth axis on the left. So this dialog allows you to modify the axes. It allows you to turn off an axis if you don't want to see it. I know some customers that turn off the time axis because they know that it can be confusing to customers. You can also decide if you want to use the auto increment value or override it and put in your own value. So for example, if you want to force the position axis to always put a label every 1 meter instead of the default value, you can do that. Now, sharp-eyed viewers here are going to notice that the depth axis can be replaced with an elevation axis. This is possible, but it takes a bit of time to explain it. So it's another topic that I'm going to cover in the next LineView webinar. You will also see that this dialog allows you to reverse the display direction of the GPR line. So if I click on this button here, reverse direction, Notice what happens with the line. It's now flipped over, so it's starting at about 34 meters on the left and going down to 0 on the right. And so this is really handy when you've collected GPR lines in a zigzag pattern, and now you want to compare them plotted in the same direction. All right, the last tab I want to talk about here is the legend, which we, again, remember, it's the text that appears down below the section. So this tab allows us to change the information that appears in the legend. So I can click on things, I can change the order, I can move one up, move it down. So let me turn all the possible settings on and then apply that or preview that so you'll see what appears. This is all the information that it can appear in a legend if you'd like it to. So you can control what information appears and what order it appears in. The long and the short of this entire webinar has been to create an image that we are happy with. And once we've done that, it's now time to do something with it. So the first 4 buttons on the toolbar here are actually ones for saving the image in various ways. This one will allow us to save the image to a graphics file like a JPEG or a bitmap. There's an option to copy to the clipboard, so we can copy it and paste it into another file like Word or Excel. We could send this image to the printer. We have that connected. Now the last button, the one that has green on it, it's called the Save Image button. It saves the image, the current image in the window, and attaches it to the project file. Remember the GPZ file that you're currently working with in EKKO Project. This image is then available to include in the GPR summary report, which is a PDF file generated from EKKO Project. Now there's a whole webinar that describes the various reports that EKKO Project creates, including the GPR summary report. So you might be interested in watching that one. You may want to plot more than one GPR line at a time in LineView. If you are currently in LineView and want to open another GPR line, use the drop-down. I've actually been using this quite a few times during this webinar, but if you move up here, there's a drop-down which will actually give you a list of all the lines in your project. Now in this particular project, there's only 2 lines, so I don't have a lot of choice. But if I want to open up the second line, I can select it and it opens up. So now I have 2 lines. I have both lines plotted. Now we can arrange these lines in various ways. There's 2 buttons on the toolbar. One will tile the windows vertically, one will tile them horizontally. So whichever way you want to look at your data, or if you just want to grab an image and resize it, you can do that. All this is possible to do. There's also a slightly dangerous button that allows you to open all the GPR lines in your project. Now it's not a big deal if it only has a few lines, but if your project contains grids and lines, you can easily have dozens or even hundreds of GPR lines. So you want to be careful about using this button in this situation. LineView will start opening the lines, and you may even eventually run out of RAM on your computer, and LineView will stop. You can also open more than one GPR line in LineView from EKKO Project. So if I actually come out of LineView and go back to EKKO Project, I can open up multiple lines by checking them. So if I use Project Explorer, I check the 2 lines, and then I go up to the LineView button on the toolbar. The same thing will happen here. LineView opens, and I will have both windows open. So that's another way of quickly opening 2 lines. Now you'll notice that these 2 lines that I have plotted here are actually using different view settings. And that's fine, they're completely independent. All the things that we've been talking about, this whole thing, different color palettes, different gains, each window can be absolutely independent. But there's often times that you want to plot things the same way. So click on the image that you like the plotting capability of. So for example, if I like the seismic one here, I click on that to give it the focus. Now I open up View Settings, and one of the options here in the bottom are these two checkboxes that say Apply to all open lines or apply to all lines in the line set. Now, in this case, they're both the same to me because there's only two lines. But if I say Apply to all open lines and I hit OK, then both lines are plotted exactly the same way with the same view settings. Okay, we have gone end to end with LineView. There are certainly more details, but if you followed everything I've done today, you are well on your way to generating GPR line images for reports and presentations. Now, the best way to learn software is to use it. So I encourage you to try and practice with LineView as soon as possible and practice the things we talked about today. If you don't have a copy of EKKO Project, we can send you a demo version to try. Email me at the email address on the screen, and we can get you set up with a demo version. I plan on having another webinar that goes over some of the more advanced features of LineView, things like elevation plots, user gains, other types of gains such as AGC, wiggle traces, and linking windows. So watch out for an email announcing that webinar. Thanks for attending today's webinar.